So let's say I have a matrix M, which is represented as A, B, C, D. If we wanted to find the determinant of this matrix M, what that would be is AD minus BC, which is we're multiplying this point by this point and this point over here. Okay. However, it's all good and fine that this is how you calculate a determinant, but have you ever wondered what a determinant actually represents? So in order to understand that, let's try to illustrate, try to follow along with me on this example. So in order to illustrate that, try to follow along with me on this particular example. So imagine I have an X and Y plane over here, with 1, 2, 3, 1, 2, 3, and I pick a certain point, like let's say I call this point 1, 2, where X is 1 and Y is 2. And what I do is I create a rectangle here. I'm going to create a couple of matrices here. So I'm going to call this one M1, which is equal to 1, 0, 0, 1. M2, which is equal to 3, 0, 0, 1. And M3, which is equal to 0, 0, 0, 1. Right? So if we were to represent this point over here as a matrix, a 1 by 2 matrix, as 1, 2, and we were to multiply this matrix by this 2 by 2 and produce another matrix, that would also give us another 1 by 2 matrix, which would provide us with P1 and P2. Now P1 and P2, we could treat this as another point. So let's say I take this 1 by 2 point over here, which is a square, as I've shown before, and I multiply it by M1 in order to get a new set of points and map it out. What would that look like? So taking the first point over here, I'm just going to call this one as, let's call this R, the vector R. So let's say I multiply R by M1, right? So what's that going to look like? It's going to be 1, 2 times 1, 0, 0, 1, which is going to be rows times cols, right? So it's going to be 1 times 1 plus 0 times 2, and that's going to be the first point, which comes out to 1. And then the second point is going to be 1 times 0 and 2 times 1, so it's going to be 2. So that means our point, our P1 and P2 is 1, 2. Now doing R times M2, we now get 1, 2 times 3, 0, 0, 1. Now I'm not going to go through the whole rows times cols again, but you can do it yourself just to follow along. And this comes out to 3, 2. Now our last matrix is going to be, our last operation will be R times M3, which is going to be the same point, 1, 2, that's a 2, times 0, 0, 0, 1. And this comes out to, what is that over here? 0, 2. So given these three operations that we just did, if I were to plot this out on an XY graph, let me try to make that a little straighter. And let's see over here, 1, 2, 3, and 1, 2, 3. Okay, let's start with the first operation. So we ended up with x-axis, x point 1 and point 2. So this is going to be our first rectangle over here. Now let's go over to the second one, which is 3, 2. So 1, 2, 3, and point 2. So it's over here. This is our other rectangle after we multiplied from the second operation. And our last one, which is just 2, 0, 2. So that means that there is no x component and it's just a straight line going up here. So we know that our original point R, the original rectangle that we drew, was 1, 2. So let's try to analyze that for a second. This was the original rectangle. I'm not going to really draw it over these lines, but I'll just highlight it in here. This was the original rectangle. And what was the area of that rectangle? So if we take a look over here, we had a 1 by 2 rectangle, and so if the area for that, it's trivial. It's 2 times 1, which equals 2. So we know that the area of the yellow operation that we just did, that returned back the same operation. So it would also be, it's also a 1 by 2, which is area 2. Now let's take a look at the green one. Our green ended up with 3 by 2. So the area for this was 6. And finally, our blue was just a line. So it's 0, 2. So the area for this is 0. What exactly does this have to do with the determinants? So let's take a look at the first matrix that I did. M1, that was 0, I'm sorry. M1 was 1, 0, 0, 1, right? And the determinant for this, based off of the equation that I showed earlier, you can do A times D, B times C. So we're going to get 1 plus 1 minus 0, I'm sorry, 1 minus 0, which equals 1. So the determinant of this is equal to 1. So now let's change the determinant. What's the determinant for M2? That would be the determinant of 3, 0, 0, 1 based on the matrix that I showed earlier. And that's going to be 3 times 1 minus 0 times 0. So that's going to equal 3. And if we take a look over here and calculate the determinant for M3, we're also going to get 0, 0, 0, 1. So it's going to be 0 times 0 times 1 minus 0 times 0. So the determinant for this is 0. So the original point that I created, which was R1, 2, I multiplied it by this matrix M1 and I got back 1, 2. So the area for my original R was 2, and the area for my M1 matrix after I multiplied it was also 2. So we can see here that the area did not change, right? So let's take a look now at R, which was 1, 2 multiplied by M2. Now my original area was 2 and now it became 6. And finally, if we look at R times M3, we see that the area is 0 for M3 after I did this multiplication. So we take a look over here, the determinants for the first matrix is 1, which represents the 1 scaling. The M2 represents 3 as the 3 scaling since the area of 2 became 6. And the determinant for M3 is 0 since the area transformed into 0. What the determinant represents is that it's a scaling factor. That's terrible writing. It's a scaling factor for what the matrix does to its input. Like if I just did area over here, if this was 2, 2, 2, 2 times, and M over here is 1, and 2 times 3, and 2 times 0, that's basically all the determinant is. It's like I'm taking the area over here, the original area, which was 2, and I'm multiplying it by a scaling factor. And that's all the determinant represents. The thing that you wanna, the caveat though about this determinant is that it doesn't tell you in what direction the area is increasing, right? So it's not a two-dimensional. That's why we need the whole dimension of the matrix right here to tell us what direction it's increasing. But if you calculate the scalar determinant itself, it at least gives you an idea of what it's doing. Is it getting bigger? Is it getting smaller? Or is it losing a dimension? In this case, you can see that because the determinant was 0, it lost a dimension. It went from a 2D space to a 1D space. So it went from a rectangle over to a line, which was 1D to 2D. The same also applies for more dimensions than just 2. If I had a cube over here, let's say the volume was originally 1 for the cube. Because it lost a dimension, it's now a 2D rectangle. And so the volume is 0, V equals 0, since you're doing length times width times height. If one of these is 0, that means that your volume is going to be equal to 0. Correspondingly, since in this example I showed you, since height times width equals the area, if one of these two is equal to 0, then that means that your area is also 0. Hopefully that explains what a determinant is. If you guys were able to follow along and you liked the video, then please hit the like and subscribe button. Thank you for watching.